1, number of beautiful integers in the range. So for this problem, we are giving a range low and high, and this low and high is going to be inclusive. So we need to meet two conditions. So the first condition is that the count of even digit in the number is equal to the count of odd digits, and the second condition is the number is divisible by k. So for example, from low to high, 10 to 20, we're going to check all the numbers, but the only possible case is going to be 12 and 18, because 12 divisible by 3, yeah, it's going to be 6, and 18 is also divisible by 3. 12 divisible by 3 equal to 4, and 18 divisible by 3 equal to 6, and this is okay. And also 12 and 18 is in between low to high, yeah. And in the let me just explain it once again, because I did it wrong. Because for 12 there's a even digit and another one. This is an odd digit and this is an even digit, and the number is equal. And also similarly for 18, 8 is even and 1 is odd. Yeah, there's only one odd and one even. And also this number is just in between low and high, and it is also divisible by k. Yeah, so this is exactly what we are doing. And this low and high is going to be 10 to the power of 9, and this k is going to be 20. So it is clear that this problem is going to be solved by digit dp. Yeah, so the only difficult part is about this k. As this k is 20, it means it is okay to solve it. Otherwise, if this k is really big, maybe 10 to the power of 9, definitely it didn't work. So the idea is that if a number is divisible by k, what does that mean? So for example, if k equal to 20, so definitely 20 is divisible by 20. Yeah, but how should we know that? For example, 140, how should we know this number is divisible by 20? Yeah, so we're going to check them one by one. We're going to check each digit one by one. So for example, if 1 is not divisible by 20, and then we're going to accumulate it to 14. So 14 is not divisible by 20, so we're going to keep a 14. Yeah. And then 140, it is divisible by 20, so that is okay. Yeah, but it's going to make the number smaller. So 140 divisible by 20, it's going to be 7. Yeah. So if we have another number, maybe still 0. Yeah. So this means what left behind is only some number between 0 to 20, 0 to 19, which is makes the k which makes it possible to solve the problem, because otherwise it's going to be time limit exceeded, because this k is only 20. So this means it is possible to solve it. Otherwise, the time complexity is going to be the number of the digit 10 times this k is going to be 20. If this k is 10 to the power of 9, definitely it didn't work. Yeah, so this is the basic idea. Maybe let's just use another example. Maybe this k equal to 3, and this number is really big. So for example, it is 144. Yeah, actually we are not checking all the possible numbers. We are just checking 1. Is 1 divisible by 3? No, it is not. And then we're going to use 14. And after this 14, we're going to use 14 modulo 3. So what left behind is 2. Yeah. Now we're going to use this 2 to accumulate with this 4. So it's going to be 24. And 24 is divisible by 3, modulo 3 equal to 0, so this means it is okay. Yeah, so this is the basic idea. So if we have a 144, so we're gonna have a 1 and 1 4. Actually we have a 0, but we don't need it. We just use 14. Yeah, we just use something like 140. If it is divisible by 3, what's left behind is 2. but as we have another 4, it's going to become 24. Yeah, because 3 times 40 is going to be 120. 140 minus 120 is going to be 20. 20 plus 4 is going to be 24. And then we're going to use 24 modulo 3, it's going to be 0. Yeah, this is going to make the problem really easy to solve, otherwise it's going to be time limit exceeded. Now let's just try to use this DP idea to solve the problem. So I always play S1 and S2, as there are two strings. It's going to be string of low minus 1 and the string of high. Yeah, because this low and high is going to be more than 0, definitely we can use this low minus 1, otherwise we cannot. Because this low is at least 1, 1 minus 0 is going to be 0, so this is okay for us. Now we're going to use a case, and we're going to use a DFS function. So inside this function, we're going to prepare the index I. Let me think about it. We're going to also need a value. This value is just to accumulate this value. Maybe, for example, the low one, high is 10. Maybe this value is 9 or 8. This is just our value of the number. And then we're going to prepare a difference, because the difference can be 0 or 1. So this means if this number is odd, we're going to plus 1. If it is even, we're going to minus 1. So finally, the difference is going to be 0. And as always, we're going to prepare its limit and its num. And finally, we're going to prepare a string s. Yeah, as you can see, there are so many variables, but it doesn't matter, because the idea, the template is going to always be the same. If I equal to the length of the string, we're going to return an integer, its num, and if its num is true, and val equal to 0, and difference equal to 0. Now we're going to set the result, and if not its num, we're going to update the result. And here, this value and the difference going to be the same, and this is the limit going to be false, and its num going to be false, and the string going to be the same. Now we're going to prepare low and high. Low going to equal to 0 if it's a num, else it's going to be 1, and high going to be the integer of si if it's limit, else it's going to be 9. Now we're going to check all the digits. So for D in range from low to high plus 1. Yeah, as this is a for loop, we need to update the value and the difference. So we're going to update it as a new value. It's going to be 10 times the value plus this digit, modular the k. Otherwise, it's going to be time limit exceeded. We have to use a modular k, because this is exactly how to calculate if it is divisible by k. Actually, it is modular by k. We can use this kind of calculation to decrease the time. Otherwise, this value is going to be really big. Currently, it's going to be just k. And we also need a new difference. It's going to be the difference plus 1 if d modulo 2. If it is odd, we're going to plus 1. Otherwise, we're going to use difference minus 1. And we're going to update the result. I plus 1. It's going to be the new value, new difference, and its limit, and d equal to high. And currently the its num going to be true, because we select a number, and the string going to be the same. Finally, we're going to return the result. Yeah. So what left behind is we just need to call the function. It's going to be 0, 0, 0, and the its limit going to be true from the beginning, and its num going to be false, and with our string s1 and s2 and s1. So here going to be s2. And now let me just copy and paste. So here going to be s1. And now the problem is going to be a little bit different, because this is just a template. I didn't explain every detail about the template, but for other DP problem, I've already explained why I'm gonna use the source kind of template, because it can make the problem really easy to solve. Otherwise, how you can think about so many variables, how you can think about there are even 6 variables inside the function, inside the DFS function, and there are so many conditions to check. And that is why we're gonna use a template. So for the template, this one is always the same. Only the difference is the value and the difference. And for this value and difference, we just need to use this kind of formula to check according to the description. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases and it's pretty fast. I think that's all about it. Thanks for watching. See you next time.